Hi everyone, and welcome to the Creating Measurement Response Options video lecture. In this lecture, we're going to continue our discussion of operationalization by talking about how you design variables once you know what questions you're asking. When researchers create their variables, they make important decisions about what type of response options they're going to provide for their questions. Their decisions depend not only on the concepts themselves, but also on the research project and the necessary data needed to answer the research question. For example, let's say you wanted to study attitudes towards immigration. You may need to know exactly how old someone is in order to compare their attitude versus someone younger or older. But what if you wanted to compare generational attitudes? Maybe then instead of the age you want the respondent, you want just the respondent to self-select which generation they're a part of. So are they a baby boomer? Are they Generation X? Are they a millennial, etc.? So the number and type of response options that you use is going to depend on your specific data needs. There are two important rules to keep in mind when you're creating response options. The first is that options must be mutually exclusive. This means that there cannot be any overlap between the response options. If you're taking a survey, you need to know which option you're supposed to choose. You should not be able to see yourself in two different categories at the same time. For example, look at these two survey questions. In one, you're given response options that overlap. Which option do you choose when you're 30 years old? Because 30 shows up in the 20 to 30 category and the 30 to 40 category. Thus, these categories are not exclusive. The revised version makes sure that there's no overlaps. The second rule is that attributes must be exhaustive, meaning that they include all possible answers to the question. This can be simple or it can be complicated. For example, if I ask you whether you're listening to this lecture at your house or not, it's an easy yes or no question. Either you're at home or you're not. But what if I asked you about your plans for Christmas? Imagine all the possible responses you could have for that question. Shown here is one of the easiest ways to make sure that your attributes are exhaustive. It's the last option, other. By including an other category, you can make sure that no matter what your participants think, feel, or behave, etc., they're going to have an appropriate option to fill in. In this study, you're actually allowed to fill in an answer choice that isn't listed, but other times you may simply have to suffice with other. And finally, the last thing to consider is the level of measurement that is appropriate for your response options. By level of measurement, I am referring to the level of precision that your options will take. Here's what I mean by that. The level of precision in your data changes based on how specific the response options are that you give to your participants. Shown here is a breakdown of some different ways to measure the variable age. On one hand, I have the most precise age measurement by asking participants to provide the specific number of years old that they are. On the other extreme, I have dichotomous categories, which means there's only two options, that are split into the age options of a juvenile or an adult. In the middle, we have options like age ranges, which allow us to order participants by their age between categories, but don't let us order participants within the specific category. We also have a list of categories like juvenile, young adult, middle-aged adult, senior, etc. So again, consider the problem with the subjectivity of this categorization. Definitions of senior change. So someone who considers themselves to be a senior at 55 may not categorize themselves the same way that someone who doesn't consider themselves to be a senior until age 65. Hence why it's important to consider the purpose of your measurement when picking your level of specificity. One last thing I want to note here is that if you are ever unsure about what type of data you're going to need, it's always best to gather the most precise data possible. That's because you can always take more precise data and change it into less precise categories. So if all my study participants told me their real age, I could categorize them as seniors, juveniles, or adults based on the set age criteria that I developed. But if my participants only tell me in the beginning they're only a juvenile or an adult, I can never make my data more precise by extrapolating their actual ages. Now, so far I've been talking in terms of more or less precise. However, in research methods, we have a specific term for each level of precision, and these terms are all considered levels of measurement. At the lowest level of measurement, we have nominal level data. This type of data is categorical only. Categorical data means that it is not numbers. Instead, it will be words, phrases, descriptions, etc. Nominal level data cannot be rank ordered, meaning there is no way to order the categories from least to greatest or highest to lowest. Ordinal data is also categorical, but this type of data can be rank ordered. Here's that information using images instead of words. Both types of data are categorical, so they are designed to capture information about non-numerical data. In the nominal category, we have the attributes of pen, pencil, and eraser. That variable is probably office supplies. Notice that pen, pencil, and eraser can't be put in any kind of order. Pen and pencil are no greater or no less than eraser. That's why it's nominal level. On the ordinal side, we have things that can be put in order, like moods, excellent, good, or bad, or fantastic, okay, don't like. But notice they're still categorical, not numbers. The last two remaining levels of measurement are both numerical, meaning that they deal with real numbers. Interval data has real numbers with fixed distances between them, but no true zero. What do I mean by true zero? True zero means that when the measurement is zero, absolutely none of what you are measuring exists, which kind of seems confusing, but think about temperature. A thermometer is designed to measure the heat in a room, right? But at 0 degrees Fahrenheit, it doesn't mean that there's no heat whatsoever. That's because Fahrenheit is an interval number. It does not contain a true zero. Ratio level data is the same, real numbers with fixed distances between them, but ratio data also has a true 0 point. The best trick to figure out whether something is interval or ratio is to determine, can it go negative and make sense? If it can go negative and make sense, it's an interval measurement. If going negative doesn't make sense, like with your age, then it's a ratio level measurement. In social science, most of the concepts we are trying to measure will have true zeros. Your hourly wage, the number of kids you have, the number of times you've been arrested, all of these are ratio level measurements because you can't have negative money or have negative kids. Now I'm going to add one last thing to this slide. Remember our previous discussion about using more precise measurements whenever possible because you can always reduce the precision? That means that ratio level measurements are our gold star. They are the most precise level of measurement possible and therefore allow you to do the most with the data set. I want you to get really comfortable identifying the level of measurement in an existing measure because this idea is going to be really important later on when we talk about quantitative data analysis. As you can see from the chart here, level of measurement affects what type of mathematical operations you can do and what type of statistics you can interpret about the data. So it's really important to the data analysis process. You don't have to know this chart right now, but we're going to revisit this idea later on in the course. Now, I have a great flow chart that will help you determine the level of measurement of a given variable, and I'm going to go over that in just a minute. But I do want to first address two special kinds of ordinal measurements. The first is numerical ranges, like 0 to 10, 11 to 20, 21 to 30, etc. They often confuse students because they look like they should be ratio measurements. After all, they are real numbers, right? The problem comes down to the range itself. Think about this example here. I interviewed 3 students and I asked that they choose their ages from the age ranges provided here. This is how they break down. Kamal and Arya are between 10 and 19 years old, and Talia is between 20 and 29 years old. So I can easily determine that Talia is older than Kamal and Arya. But what about Kamal and Arya? Is Arya older than Kamal? Is Kamal older than Arya? Or are they the same age? Because we used an age range to measure their age, we can never determine the order of everyone in the same category. Thus, numerical ranges are considered ordinal categories, not ratio values. The other type of ordinal measurement that you'll see a lot is the Likert scale. Likert scales are designed to rate the intensity of a person's attitude. Likert scales are unusual because they use statements, not questions. So instead of asking you, do you think this product was a good idea or a good value, Likert scales will ask you how strongly you agree or disagree with the statement, I believe this product was a good value. You've all used Likert scales quite frequently because they're the primary questionnaire type used for student evaluations and all kinds of the restaurant surveys and random customer service things that you've answered over the decades. All right, well, that concludes the first part of this week's lecture. In the next video lecture, I'm going to actually show you that flow chart and go over some practice problems to determine the proper level of measurement. Thanks for watching, everyone.